Hey everyone, welcome back. Today we are diving into a critical performance matrix in system design, which is throughput. So, what is throughput? Throughput, throughput measures the amount of work done or data processed in a given period. That means throughput tell us how much data a system can handle per unit time. It's often measured in request per second or transaction per second. For instance, an e-commerce site might handle hundreds of transactions per second during peak hours, for example. But why does this matter? Throughput is essential for understanding the capacity of our application. A system that can handle a sudden surge of users or data could lead to bottlenecks, slow performance, slow response, or even crashes. By tracking throughput, you can scale your system appropriately and keep users happy even during peak loads. Okay, what are the measures? What are the measuring of throughput? So, to measure throughput, you might use metrics like request per second, like how many HTTP requests to your web applications process in 1 second, or transactions per second, like common for database operations, monitoring, and logging tools. Um, Logging tools also can help you track these metrics in real time. So you will know exactly how your system is performing. So when you want to measure your throughput, it's like how many requests per second or how many transactions per second. But what are the factors that impacting the throughput? There are first we have hardware resources like CPU, RAM, disk, I/O. We have network bandwidth, like how fast data can travel between servers and clients. We have concurrency and parallelism, like how well your system handles multiple tasks at the same time. We have code efficiency, like inefficient algorithms or poorly optimized code can hinder throughput. Improving throughput can involve adding more servers, optimizing code and queries, or fine tuning your network infrastructure. It's all about eliminating bottlenecks and maximizing resource usage. Okay, let's give some tips to increase throughput. First, use load balancing, like distribute incoming requests across multiple servers to avoid any single point of overload. Number two, use caching, like cache frequent access data to reduce load on database, also to reduce the latency as well. Number three, scalable architecture, like use microservices or serverless architecture to scale parts of your system independently. Four, efficient database. Optimize query performance, use indexing, and choose the right data models for fast reads and writes. Each of these strategies helps ensure your system can handle increasing loads without sacrificing performance. And in the future videos in this course, we will talk about each one of them in details. So it's done for this one. So we need to make like a wrap up or a sum up. So to sum it up, throughput is about how much work your system can process over time. Tracking metrics like request per second or transaction per second will help you pinpoint bottlenecks and plan for growth. If you want your application to keep pace with user demand, it's critical and crucial to optimize your throughput. That's thanks for watching, and don't forget to like, subscribe, and comment if you have any questions or want to share your own experience with throughput.